Okay, welcome back, ladies and gentlemen. Today is a review day slash some new stuff about circuitry. All right, so first of all, I'm not going to go over what a radian is again, because I've done that so many times. But you should know, if I asked you to draw a radian, you should know how to do that. Okay, next. Let's say I said, that's an angle. What is it? I know you don't know for sure, but assuming I picked a common one, you should be able to tell me what angle that is. And also, I hope you're considering the possibility of telling me an answer in radians. Give me a radian answer and also give me a degree answer. If that's too vague for you because you need to know exactly what the other sides are, I could throw this little piece in and say how big this is, but this is not the angle in question. But what if this one was 45 degrees right there? Doesn't that kind of tell you what the other ones are? Tell me an answer in radians, tell me an answer in degrees, and tell me one answer that's negative. So the spot I want is here. I'm just trying to show you, if I told you that angle, it helps you to figure out the other big open angle. I want the blue angle. All right, I'll pause while you try that. Okay, so I hope you knew that there was a bunch of 45s. How many 45s? One would get you here, two would get you there, three would get you there. 3 45s, also known as 100 and, what is it? 135. Good. And if they're 45-degree wedges, those are all pi over what's? Pi over 4s. 1 pi over 4 gets you here. 2 pi over 4 is halfway, which makes sense. That's also known as pi over 2, right? 3 pi over 4 would have been a correct answer. Now, I did ask you to give me one that's negative. So if you did one that's negative, you would have had to come from this way. That's going to be how many pi over 4s? Negative 4 pi over 4s. One more, negative 5 pi over 4. And if you wanted to do it with negative degrees, you'd say negative 180 gets you here, plus another 45. What's 180 plus 45? Negative 225. Did you have to have all those? No, but you needed to have one negative one and at least one with radians. Make sense? Okay, that's like the basics. Because now that we know where that spot is, I can ask you for sine, cosine, and tangent of 3 pi over 4. Find sine of that, cosine of that, and tangent of that. Hence, some of them will be negative. I'm going to pause for a second while you find sine, cosine, and tangent of 3 pi over 4. You want to make a triangle there. Once you got a triangle that's labeled with all the sides and all the angles, should be pretty easy. This one, I'd like you to check with the kid next to you and see if you get the same 3 answers as they do. Leave your answers in terms of like 1 over square root of 2 or root 3 over 2. It'll have square roots in it, basically. I'll pause while you try that. Okay, so I hope. Now, this is kind of weird. We were all focused on this angle over here, but now it all becomes about not that angle, because to make the right triangle, you need to take care of this angle. Now, this is called a reference triangle, as in you can't make a right triangle with the actual angle, which is this one. This big open angle here, you can't use that angle, so you use this other angle. And that's called the reference triangle. All right, so hopefully you figured out this is 1 square root of 2. How many of you were smart enough to check for negatives? Raise your hand if you caught the negatives. That's awesome. It's so easy to forget. Negative and negative. Nope, wait a minute. One of them is negative. There we go. Good. Okay, now, this angle right here, sine of it is opposite of hypotenuse, and so 1 over root 2. Cosine of it is adjacent over hypotenuse. That uses that negative, and so it's negative 1 over root 2. And last but not least, tangent TOA, opposite over adjacent, 1 over negative 1, which is negative 1. Now, you could put over 1, but 1 over 1 is 1, right? This is one of the ones that messes with people because they feel like they only got one of the sides when somebody tells the tangent equals 1. But it's really 1 over 1, so they're getting 2 sides. You just don't forget that that's actually like over 1. Okay, so anyway, moral of the story, you got sine, cosine, and tangent of a strange angle you never even knew where it was before. And you're doing math that you probably would have thought only a calculator could be able to do, but you're doing it just in your head, which is cool. All right. Now, what if I had asked you to do the sine of 263.8 degrees? That wouldn't be able to be done in your head. Why was this able to be done in your head? Because you knew this 45, 45, 90 triangle. You had it memorized, right? What's the other one we have? Besides 45, 45, we have 30, 60, 90. And that covers most of the spots that you'd need to know. But it doesn't cover all of them. Oh, wait, one more thing I should mention. Do you remember the whole ASTC thing I told you yesterday? ASTC. Were we in A, S, T, or C? We were in S. And what does that mean again? That S is sine, and sine is what? Positive. Notice it was the only one that was positive. The others came out negative. In this quadrant, the only thing that would have come out positive would have been tangent. All right. So later, when they give you clues like, oh, by the way, they often aren't as nice as, you're in quadrant 3. If they say that, then cool, you know for sure where to draw the triangle. But if they might say, tangent's negative while sine is positive. When you go, okay, well, if tangent's negative, then where must I be? All right, I'm going to give you one like that, where I just wanted you to tell me, what quadrant am I talking about? Tangent's negative, and sine is positive. This is a fascinating drawing, but I need your attention. Tangent's negative, and sine is positive. Tangent's negative, sine is positive. Now, these are not quadrant names, but I'll sometimes refer to them, are you in A, S, T, or C? Technically, A is 1, S is 2, T is 3, and C is quadrant 4. All right? If sine was positive, I did say that, didn't I? Then do you get I can rule these two out? If sine is positive, I have to be in one of the top two. And then, where of those two is tangent negative? Over here, because tangent's positive here. All of them are positive here. So therefore, I had to be in quadrant 2. Raise your hand if you had that one right. Okay, good. All right. Now, that often isn't going to be said the way I said it. It's not going to be tangent's negative and sine's positive. They're going to write something like this. Cosine of the angle is negative 1 over root 2. And sine of the angle is less than 0. Do you get from what I just wrote? I could have said cosine's negative and sine is negative. But you see, it doesn't say it directly, but if you think about it, it's telling you the cosine's negative and sine's negative. Okay, so what quadrant do I have to be in? Figure out where cosine's negative and sine is negative. This guy. You could say T or you could say quadrant 3. Okay. And then, let's finish the question. Because what is the question? What's the thing I don't know? Theta, the angle. And remember, if you do figure out the angle, oh, it's so painful when kids go this far and they get this and then they go, oh, that's 30, so the answer is 30. Nope. If you're there, the answer isn't 30. The answer is 180 plus 30 more would be like 210. Get what I'm saying? The answer to a question of what angle is this, if the answer was 30, you'd have had to be here, because that's the only place where 30 really is. All right, so I'd like you to remember that so that you don't just figure out, oh, I'm in the 30, 60, 90 triangle, or I'm in the 45, 45, 90, so my answer is 45. Your answers are not small numbers. If you're in here, you get your answer has to be bigger than 180, unless you're in negatives. All right. But we usually say don't give negative answers. It'll say that by saying theta must be between 0 and 360. That means not negative. All right, so only give me a positive answer. It's over 180. It's less than 270. All right, I'm going to pause for a second while you try to figure that one out. If you draw the right triangle, it'll become easy. Make a right triangle with sides and angles labeled. Easy question. So, did you say that, what information did Mr. Server tell me? He didn't tell me the angle, but he told me sides. I hope you went over here and said, okay, he told me sides. Which sides did he tell me? Oh, yeah, cosine is adjacent over hypotenuse. He told me the adjacent side was 1 and the hypotenuse was square root of 2, and only one of them can be negative. Since it's negative because of that sign right there, then that one must be negative. And cool, I'm starting to build my triangle. I got 1 and I got a root 2, and then do you get that this one has to be 1 then? But actually, since it's going down, negative 1. All right. So then what was the angle? And hopefully you didn't just get suckered into saying 45, because it's not 45. It's 180 plus the 45, which you could say is 225. Raise your hand if you had 225 as a possible answer. Good. What if you said it in radians? Then you got to say a whole bunch of 45s, which are actually pi over 4s. How many pi over 4s? Well, to get here, it's 4 pi over 4, so it's one more. So it's 5 pi over 4. All right, cool. So that's the answer to the question, is what's theta? Theta had to have been 225, or 5 pi over 4. Does that make sense to you? How did we get it? Because we knew the sides. Once we knew the sides, we could figure out the angles. What you had last night is you had a problem that was kind of like that, but you had, like, this side was like 2 and this side was like 11, and then you had to figure out what that side was. Well, first of all, you can do a squared plus b squared equals c squared, but that's really long and slow. Let me show you a shortcut that's pretty cool. You get that at the end of the a squared plus b squared equals c squared thing, you always end up taking the square root because everything's been squared. So I know this answer really fast. It's the square root of, and both of these had to get squared, right? So 4 and 121, and then I either add them or subtract them. Think about it. What do you think it is? Do you think I would add these together to make this side? No. So then it must be subtract. Therefore, it must be square root of 121 minus 4. You get how pretty that was fairly fast? And I talked you through it. If you don't have to talk somebody through it, you can just do it really fast. Why is that handy? Because on your next test, you're going to have to do that kind of thing. Let me give you another one. Let's say I give you this, and I say that's 3, and that's 7. How long is that? I can do it in 5 seconds. Can you? Try it. Hint, start with the square root. Get square root of 40. See how that's really fast? Square root of, and then 49, and then 9, and the only question is add them or subtract them. On this kind, subtract them. Because these two added together shouldn't make the smaller side. That wouldn't make sense. You take the two smaller sides and add them up to make the bigger side. All right, so there we go, square root of 40. Why do you care? Because if I just gave you that, then this angle's called theta. We don't know what that is. Nobody here has memorized the 3 square root of 47 triangle. I'm really doubting it. Okay. So the typical question wouldn't be what angle is that. The question would be, if they told us originally the opposite and hypotenuse, they must have told us sine of the angle was 3 over 7. Oh, I got to remember this is negative 3. Whoop. There we go. Most common mistake in circle trig. If you're getting those negatives, you almost saw me do it there. So do you get, by telling you two sides, you could have created this triangle, figured out the third side of it, and then what would they ask? What the angle is? No, nobody knows that. But what we could ask you is, what's cosine of that same angle? Don't overthink this. This is a super simple question. What is cosine of that angle? Adjacent over hypotenuse, right? So, row 4, person 5, that's you in the back. All right, because you just did the adjacent over hypotenuse, root 40 over 7. Should cosine be coming out positive down there? Yeah, because all students take calc, cosine does come out positive down there. Is all this coming together for you? Hoping so. All right. So, what haven't you done yet? We have never done these yet, and it's kind of an oversight on my part, but we've gotten through a lot, actually. Honestly, it's Thursday. Your test isn't until Tuesday, and you now know how to do everything on the test except this one thing. So I kind of got ahead in some areas, but behind in this one area. Where is that spot right there? Have you got it memorized yet? Pi over 2, also known as 90 degrees. What is the sine of 90 degrees? You're not going to get it from a triangle. You still can't do a right triangle and do sine of this. Why can't we do sine of 90? Because it needs the opposite in the hypotenuse, and the opposite is the hypotenuse. See what I'm saying? So you can't do sine of 90 from that. That same problem happens. Oh, and also, you can't draw a triangle like this. See what I'm saying? I actually tried one year to show people how that could happen. If you tried to draw a triangle like that and then made this side 0, but it just messed with people's heads too much, so I'm not even going to try showing you that way. You're probably messing with your head right now. So anyway, so how do I find the sine of 90 degrees? You know it can happen, right? You can type in the calculator sine 90. There's an answer for it. So what are you doing to get that answer? All right, here's what it boils down to. Do you remember me telling you this little example where you would make a unit circle and that this would be like x and this would be like y, and then the radius is 1 on a unit circle? Does this ring a bell? Do you remember that? Okay. Then what is the definition of the sine of this angle? Which one was that? Which letter was that? Sine is y. Sine y. Sine of that angle is the y of it. It's the height of it. Why? Because the opposite over hypotenuse, right? Opposite is y over hypotenuse is 1. Y over 1 is just 1. So sine is y. Sine y. Say it. Good. You need to get those stuck in your head, because then you'll remember that cosine must be the other one, and therefore what's cosine? X. And then what's tangent? Y over x. Let me show you why this is cool. Okay. That spot right there is on the unit circle 0, 1. Isn't it? That dot right there, if we are truly on a unit circle, then this distance right here has to be 1, right? So what's the sine of 90? Come on, put it together. Sine of 90. How many of you are whispering 1 to yourself quietly because you understood what I was saying? A few of you. Why would it be 1? Because it's the y. We just got done saying sine is the y. The y height, this height right here, that is the sine of the angle. So which of these two is the y? That one's the y. What is sine of 90? It's 1. Grab a graphing calculator. Would you please type in sine 90, enter. I need you to see it, that it actually works. Sine 90. Make sure you're in degrees. Did you get 1? All right. What do you think cosine of 90 is? Take a look before you type it in your calculator. Cosine of 90. Isn't that supposed to be the x? And therefore, wouldn't you predict it would be 0? And is it? It is. See? Okay. What's tangent of 90? Well, it's y over the x. What's the y? 1 over what's the x? What's 1 over 0? Try typing in tangent 90 and see what happens. You can't have a 0 in the bottom, right? That's a domain issue. All right. Now, from doing that, do you get that we can also find the sine of 180? Because it's right there. What is that spot on the unit circle? What comma what? -1 comma 0. So what would you predict the sine of 180 is? Sine is which letter? Sine y. So what's the sine of 180? 0. What's the cosine of 180? -1. What's the tangent of 180? Don't say undefined just because there's a 0 involved. What if the 0's on the top? Then it's just 0. Would you please type in tangent of 180? And I betcha it's the 0. That make sense? All right. So to see if you really understood that, would you please figure out the sine, the cosine, and the tangent of 3 pi over 2? That's another one of those spots where you cannot draw a triangle. Sine, cosine, and tangent of 3 pi over 2. We're having a class in here, you guys. Keep moseying along. All right. If you get this, you get everything. And then we can just review. With a little top 20 turn in tomorrow. JG, where are we? Kind of. Aren't we between two quadrants? Between which two quadrants? You think we're here? Because that's between second and third. Here's quadrant 1, here's quadrant 2, here's quadrant 3, here's quadrant 4. We're not between 1 and 2, or 2 and 3. Where are we? Between 3 and 4. All right. So we are not there. We are here. And if you were going to describe it as far as quadrants go, you'd say you're between 3 and 4. Okay? That's our spot. Raise your hand if you were in the right spot. Okay? Now, how do you do sine of it? You got to know what point you're at. Remember, if we're on the unit circle, this distance is 1. Well, technically, it's going down 1, and so therefore, what point are we at? What comma what? 0 comma, careful, -1. You're going down, right? Because this is going down 1, so I'm going to say it's -1. And then, what's the sine of that? It's the y. So you should have had -1. What's the cosine of it? 0. And what is the tangent of it? It's always going to be two things divided, and a lot of times there's a 0 involved, right? And therefore, a lot of times it doesn't work. Is this one of those times where you get no solution? I agree. You can draw that if you want to. All right. Okay. So those are called something. I said the name yesterday. Has anybody happened to remember it? There are 4 of them that would give you a hint what they're called. Quadrantal. Those are quadrantals. And again, not in context. That wouldn't be something that would stick in your head. But now you can know that name. You're not going to be tested. What are these called? Here's an R3. What is it called? No. But if they said, name the quadrantals, you might have to go, oh yeah, that's those weird ones that you can't draw triangles for. And which ones are they? Well, 0 is this guy. Could it sort of also be called 0? Ooh, that's a weird thought. What's the difference between 0 and 0? One of them is in degrees, and what was the other one in? Radians, which have no unit. Okay, and then could it also sort of be called 2 pi? Isn't that the spot where you get to 2 pi? Here's where pi is. Isn't that the spot where you get to 2 pi? Yeah, it can kind of be called 2 pi. But if you have a choice between 0 and 2 pi, always use 0, because 9 times out of 10, the directions are going to say, give your answers between 0 and 360, which is also known as 2 pi. And it'll allow you to be 0, but it won't allow you to be 360, because 360 and 0 are the same thing. You know what I'm saying? And you got to pick one or the other. So again, if you're picking between two things for that, pick the 0. Never the 2 pi. All right. So you now covered everything that you need to know. So let's, considering where we are in the hour, we need to probably take a look at the homework. I'm going to pause for a second while we find some homework again. We're going to go from this page here. And notice it says, find all of the angles which satisfy the given equation. And later we had to go back in and add this. Do you get that all of the angles is a little bit all-inclusive? Because I don't know if you figured this out yet, but you can get to 0 by saying 360 or 720 or negative 360 or negative 720. You see what I'm saying? We don't want to say all of the angles. So we're saying all the angles that are between 0 and, well, that's kind of like 360. And technically, the way we wrote this was not the way we'd have it on the test. Because you could say 0 and you could say 2 pi, because they're both in the group. On the test, it'll be like this. Don't ever use 2 pi. Why? Because you could have used 0. They're the same thing, and 0 is simpler. Okay? So let's change the homework answer to that, so you don't have to give any answers of 2 pi. Because if you would, you might as well say 0. All right, so now let's figure out where sine of a half is sine of something is a half. I said at the beginning, if there was one I would memorize, it would be this, because it would come up over and over and over again. Here's one of those times. Who's got it? You know the answer? Okay, you should have memorized this one. What? Say it if you know it. You're way overthinking this. Sine of what is a half? Sine of, all right, memorize this one. 30. Sine of 30 is a half. Why is that? Because here's 30, 60, 90, 1, 2, square root of 3. And then now if I draw that triangle, isn't it kind of no-brainer that sine of 30 is a half? So that's what you could have done, is drawn the triangle and got the answer that way. But I'm just saying this one comes up over and over again. Memorize. Sine of 30 is a half. So when they say sine of unknown is a half, you know the unknown must be 30. But wait, all of the angles. Is there another place where sine comes out positive a half? Oh, yes, there is. Oh, students, take calc. There's 2 spots where sine is 30. Sine of 30 can give you a half. There's that one, which is where 30 is. What's the other place where sine comes out positive? Quadrant what? Nope, sine is not positive down there. Only cosine is positive down there. That guy. That's the other place where sine comes out positive. See, sine is positive 1/2. There's 2 answers. There's always 2 answers. Always is a big word. There is an exception, and it's on some of the quadrantals. I won't have 2 answers for it. It'll only be 1. But if it's not a quadrantal, there'll be 2 answers. So where's the other place where sine is positive? That's this spot. So therefore, I should be able to make another reference triangle over here where that's 30. But should I just say the answer is 30 again? No. How do you get over in this quadrant? With an answer that's between 90 and 180. So it must be 180 minus the 30. Who's got 150 already written down on your paper? Okay, good job. Oh, wait. They asked for answers, and they used in radians. Okay, so then we got to quick translate. What is 30? Got that memorized? Pi over 6. I like to think of it this way. 5 times this big. 5 times 30 is 150, right? So it's 5 pi over 6s. If you don't like to do it that way, you don't have to. But I like to think, oh, it's 5 times bigger. I'll just take my pi over 6 and times it by 5. 5 pi over 6. All right, there's your 2 answers for 31. That's a fair amount of work, isn't it? But I had to explain it to you. If you were doing it without needing the explanation, it's not that bad. All right, let's find this next one. We're doing the cosine is negative. Well, right off the bat, I think you should go like this. ASTC, where is cosine negative? Well, not here because they're all positive. Not here because cosine's positive there. Do you get where the 2 triangles have to be drawn? The places where cosine is negative, which is here. And let's just get that triangle done. And then in a moment, we'll draw a triangle down in this quadrant. Okay, and what did they give me? They gave me the sides. The sides are, for cosine, that's adjacent and hypotenuse. And which one must be negative? Because hypotenusi are never negative. That one must be negative. And then what's the other side? Usually we're going to give you nice ones that you have memorized. You have memorized this one. What's that other side? 1. If it wasn't nice, if these were like 7 and 5, you do the square root thing. Square root of whatever. All right. So what was the point? What's the angle? Do you recognize, and this is another thing to just kind of memorize, across from the 1 is where the 30 is. That's across from the 1 because the smallest side has the smallest angle across from it. So I know that's a little 30-degree angle. But the answer isn't 30. The answer is all of this. So what is it? 150. And what if we have to do it in radians? Oh, it's the same as these guys. They ended up coming out the same. All right. So we need to do some that are quadrantals also, like this. Cosine is -1. Remember, when they only give you one side, make it into two sides by putting it over 1. And then you have to ask yourself, can I make a triangle where cosine is adjacent over hypotenuse, where the adjacent and the hypotenuse are the same as each other? Can't make a triangle. Which kind are the kind where you can't make a triangle for them? Starts with Q, the quadrantals. So it must be one of these guys. It's either here, or it's here, or it's here, or it's here. And for those, what I honestly do every single time if I'm doing this is I write down what all 4 points are. That's 1, 0. That's 0, 1. That's 0, -1. And this spot here, -1, 0. And then I ask myself, which of these has a cosine of -1? Which one? Oh, which one is cosine? X or Y? Cosine is X. There's a lot of memorizing in this unit. What was sine again? Sine is Y. All right, so if we want cosine, which is X, to be -1, where is there an X that's -1? There's only one spot where there's an X that's -1. It's right there. Otherwise, here the X is 0, here the X is 1, here the X is 0. There's no other X's that are -1. Has to be that spot. What's this spot right here called? Say it in radians. Pi. That's pi radians. Also known as 180 if you want to do it in degrees. All right. I did most of those 3. You should do the rest of them on this page. Okay, so do all on this first page. This one, you do not need to know how to do this, so we're going to skip this page. Solve the equation for t. Yes, this is just like before. It's just giving you a thing called the unit circle. I will talk more about tomorrow. It's kind of cool because it has all the answers on it. And there's a pattern, but some kids actually memorize this. I personally like to be able to just draw the triangles like I've been showing you how to do. But let me show you, if you had memorized it, how you could do it. 0 is actually still 0 over 1. So where is cosine 0? Then you go, oh, that's one of these kind you can't draw a triangle with a side of 0, right? If you can't draw a triangle, it's either here, 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 or here. And then which of them has a cosine is which letter again? X. Where is x0 on my little memorized chart? Where is x0? That's a spot where x is 0, and that's a spot where x is 0. And therefore, my answers are either pi over 2, or what's that spot? 3 pi over 2. Did you need to have this chart memorized to do that? No. You could have made all the same conclusions about, okay, I know I can't draw a triangle because it's an impossible one. How do you draw a side of 0? So I know it's one of these 4 things. And remember how I said if I was doing one that I knew was a quadrantal, I would just list the points? That's 1, 0, 0, 1, -1, 0, 0, and -1. And then I would pick which one has an x of 0. And see what I mean? I don't have to have this whole thing memorized. But some kids do, and they will say they have an advantage if they have that memorized. But it's a lot of work to memorize that. There is a pattern. It's actually only 8 things on there. They're just repeated over and over again. I'll investigate the patterns on that little chart with you tomorrow. Because like this is repeated over here, which is then repeated down here, which is then repeated over here, which is then repeated back up there. So there's a cool pattern on it. But again, I tried one year having kids memorize the chart, and I think it was not as good as just plain draw the triangles. And for the quadrantals, make this, those are easy to have memorized, right? You know, they're just points on a circle where the radius is 1. Okay. All right. So this page, I already did one of them for you. You do the other 2. And then this page. And this is a reminder so that you don't forget how to do law of sines and law of cosines. Why? Because we can throw those questions in the middle of a regular circle trig test. All of a sudden, you'll need the law of cosines to answer the question. See what I'm saying? So don't forget those. So which is the kind where if you have an angle in the side across from it, that's the law of sines. The one where you have a side angle side situation, side angle side, if you have that, then you could use law of cosines. All right. Do this page also, and that's all we got for today.